Hello, hello. How is everybody today? Everybody having a good week so far? I don't know about you guys, but it's always hard that first week back after a break and hard to get back into the swing of things and struggling a little bit. But we will make it through. Let's see. Let me get, let's see, we're waiting on Avery. So we'll hang on just a minute until we make sure we've got her. I'm going to pull up our notes from the other day. Okay, so what we'll do first of all is we'll get ready to check our homework. So we'll start with page 137. So if you want to go ahead and open up to that, and I'll keep watching for Miss Avery to log in. So let's see, 137 goes along with lesson 62 on mean. And hang on just a minute. I'm going to run turn my heat up. It has gotten cold in here. That wind's been blowing. It's gotten so cold. I'll be right back. Hang on a second. All righty. So let's see. Okay, Avery said she's trying to join class, so we'll hopefully she'll get in a second. Okay, so we're gonna go ahead and start with checking. Let me share my screen real quick. All righty, let's see. Hey there, Avery. I got your message, and I know that the system has been a little funny sometimes. So if y'all ever have trouble with uploading your homework, number one, if I have forgotten to put the date in there, or if it just won't let you upload, sometimes it just, I don't know why. But anyway, so y'all know y'all can always either email me or text me your homework assignments. And then also, it'll be a little different once we get back to the co-op full time. We'll be able just to check them in class. But anyway, so first of all, we are going to go ahead and start by checking our homework. So on Monday, we were taking our notes. We had about mean, median, mode, and range. And at the bottom of the page, I have our homework listed where we had 137, the bottom row of activities 2, 139, the bottom row of activities 2, and page 145 on the right column. So I'm going to go ahead and pull up those pages and we'll go through those, that homework. All righty, so the first one was page 137. There's 139. There's 137. Okay, so we were finding the mean of each set of numbers. And so remember, when we talk about the mean, we are talking about the average of numbers. We've talked about how to find an average. You add your set of numbers together and then divide by whatever, by the number of numbers that you added together. So in our first grouping of this bottom one, we have 87, 45, 92, 66, and 71. So our total is 361, and we're having to divide by 5. And so that gives us 72.2. So we would round that to a whole number of 72. Okay. So on these, it says to round to the nearest whole number. So the first one is 72. So if you have any questions about these as we go through, just let me know and I'll be happy to walk through it. The next one, our set of numbers, 345, 612, 39, 753, and 192. The sum is 2,300. We added together 5 numbers again. So when I divide by 5, I get 460. Any questions? Okay, and then the last one, 99, 78, 84, 72, 65, and 85. My sum is 483. I added together 6 numbers, so I'm dividing by 6, and that is 80.5. So that would round to an 81 for a whole number, okay? Remember, my neighbor number is a 5, so that tells me I'm going to round the 0 up to 1. Any questions on that one? Awesome. We'll move on to page 139. Page 139, we have the bottom row again. We're finding the mean and the median of each set of numbers. So what I'm going to do on this one is I'm just going to write the mean and the median for each. And it says to round to the nearest tenth. And so for the first set of numbers, our mean, did you have a question?
Yeah, I wasn't paying attention. I just did the median like you did on the top problem for my homework.
So you just did the mean or the median?
The median, because you, like when we did it in class, we just did the median, so I just did the median for the.
Okay. So you can just catch up and do that with us right now. Okay, so on this one, we were finding the mean and the median. And so the mean of this one is going to be 65, whoop, I put my decimal in the wrong place, 65.6. They told us to round to the nearest tenth. And then my median is 69. Okay, so even in this one, when I put them in order from least to greatest, I'm still going to end up with 69 in the middle. Any questions on that first one? All righty. Now let's look at the next one. When I put them in order from least to greatest, my median, looking at my middle number, is 573. And if you did the mean, it is also 573. So on this one, it's 573 for both. And then on the last one, okay, so on the last one, my mean is going to be 75.2 and my median is 76. Any questions? All righty, then page 145, the right-hand column. So let's see, we need to go on down to lesson 65. 60, lesson is at 66. There we go. So lesson 66, page 145. Okay, so we are finding the mean, median, mode, and range for each of these. So I'm just going to list them out. So mean, median, mode, range. And it said to round answers to the nearest tenth when necessary. So for this first one, my mean is 65.3. My median is going to be 67. My mode is 77. And the range is 29. Any questions on either part of that problem? All right, let's look at the next one. The next one, my mean or my average is 218.3. My median or my middle number when they're in order from least to greatest is going to be 207.5. Whoop. Pen's not picking up very well. My mode, my one that repeats the most is 287. And then my range, which is the difference from least to greatest, is going to be 145. Okay, so remember my mean is the average. My median is my middle number when they're put in order from least to greatest. My mode is the one that repeats the most. And then my range is my difference from largest to smallest. Okay, so different ways or easier ways to kind of remember mean, median, mode, and range. Okay. Any questions on that? All righty. So we're going to keep on going. And we are going to move along to, let's see, we already looked at histograms and box and whiskers. All right, so now we're starting with probability. So basically the unit that we're working on right now, we had started over or before the holidays, we had started with, we're talking about data as a whole. We're talking about sets of numbers and being able to look at them visually and being able to interpret what they mean just by looking at to see, comparing them and things like that. So our data, our graphs and things are not things that we're going to be tested on at all. We're just moving on from that. The rest of this section with mean, median, mode, and range, that's going to start our first part of what we will have a test on. Depending on our timeline, probably I'm thinking that we will not, probably what I will do is I will email you a test. So since we are out on Monday, the 18th, so basically kind of timeline, obviously today's Thursday, it's the end of this week. We will be back virtual next week. And so we will finish up, we'll be working with probability and stuff starting today, going into next week. And then my plan is to wrap everything up by next Thursday. Then I would go ahead and give you your test, but it would not be due until the next Thursday. Since we are out of school on Monday, the 8th, I think it's the 18th, we're out of school that Monday. And so it wouldn't be due till a week later. Okay, so as of now, my plan is for the test to be due on on Thursday. That's going to be the 18th, 19th, 20th, 21st. So as of now, my plan is to email you the test the end of next week, have you work on it. And it may be, depending on how far we get on Thursday of next week, it may be that I actually have a hard copy to give those, or no, I'll have to email it because we're not at the co-op next week anyway. So either way, it'll be emailed, okay? Probably by the end of next week, but it will be covering our data, working with mean, median, mode, and range, and then working with probability. Okay, so we're going to be looking at different types of probability, but that's going to be what we shift to right now. So lesson 70 in your textbook is where we're going to be working. So go ahead and turn to lesson 70 on page 153. I know we're kind of jumping around a good bit in the book, but there's just certain things that I like to put together. I like to have all of my graphs and charts and things together. I don't like how the book kind of breaks them apart. So I know we're kind of jumping back and forth, but all right. So think about the word, think about like if somebody asks you a question and you answer with the word probably. Okay. So think about when you hear the word probably, Or maybe sometimes if you're, my kids always say, if I say probably or maybe or whatever, they're like, that just means no. And I'm like, no, it really doesn't. It means that there's a chance that something could be or whatever. But so when we talk about the word probability, kind of think about it like the word probably. Okay. So we're talking about the chance of something happening. Maybe if you've asked your mom if you can go to a certain, movie or whatever it is, and she goes, oh, probably. Usually when we hear that word, we think, oh, well, we have a better chance of that happening. So that's what we're kind of thinking about with probability. Probability talks about the chance or the likelihood that something, and in this situation, we call that something an event, but it's saying the probability that something will happen when compared to all of the possible events. And so that's what it says at the top of our page right here, is that we're talking about the chance or likelihood that something will happen when compared to all the possible events. So we said all the possible results, whether desired or not, are called outcomes. Okay, so all of the possible results are called outcomes. And the notation that we use, basically when it says P of E, that means the probability of event E occurring. Okay, so that's what this little notation means, P of E. That means the probability of an event occurring. So it says probabilities are usually expressed as a percent from 0 to 100, although it is also acceptable to express probabilities as a number from 0 to 1. Notice that the latter is the decimal representation of the percentages. So think about, obviously, the number 100%. If I talk about something that's 90%, that's less than 100% or less than a whole number 1. Since we know the number 100% written as a decimal, it converts to just the number 1. So that's what we're talking about, is the chance of something happening from 0 to 100%. Okay? It says to calculate the probability of an event occurring, you divide the number of possible ways the event can occur by the total number of possible outcomes. So here's our formula right here. So the probability of an event occurring, I'm going to put the number of ways that it can occur in fraction form. I'm going to put that as the numerator, and the denominator is the total number of possible outcomes. So right now it probably doesn't make a lot of sense. We're going to put some numbers in there. And I think once you see it, you're going to go, oh, that's not a big deal. Okay. It's really not anything to be intimidated by, or it's not a big deal. So it says a card game has cards numbered 1 through 14 and each of 4 different colors. Okay. So we're numbered 1 through 14. We have 4 different colors. What is the probability of drawing a red 3? Okay, so let's think about this for a minute. So that means I've got red cards numbered 1 through 14. I've got yellow cards numbered 1 through 14. I've got green cards numbered 1 through 14. And I have black cards numbered 1 through 14. Okay, is everybody good with that so far? So think about, if I have 14 possibilities for each color, then I would multiply 14 times 4. So that means I have a total of 56 cards. Okay. So if I look down here, my denominator is 56 because I have a total, like if I had all these cards fanned out, I'm going to pretend like my fingers are cards. So I've got all the cards fanned out and I'm going to reach and pull 1. I've got 56 total cards to pull from. But of those, how many of them is a red 3? There's only going to be 1 red 3 out of all of those cards that I've got. So I've got a 1 as my numerator and 56 as my denominator. So the probability of pulling a red 3, there is only 1 out of all the 56 cards that would be a red 3. So my probability is 1 out of 56. Now, one of the things that we can do is, like it said earlier, sometimes you can see that probability is written as a percent, but you can also write it as a fraction. Okay, you don't have to write it as a percent unless your directions tell you specifically to write it as a percent. So let's go ahead and look at some examples up here in classwork. It says use the card deck and the example at the left to find the following probabilities. Okay, so we're using these same numbers right here. We're using this information right here. We know that there's a total of 56 cards. Okay, so we know that for sure. So what we're doing here is we know that our denominator is going to be 56. So it says, what is the probability of drawing a green card? So the probability of drawing a green card, and it's any green card. Okay, in the previous example, it had to be a red 3. So out of 56 cards, how many of my cards are green? What are my cards? What are all of my cards numbered? From what number to what number?
1 through 14.
They are numbered 1 through 14. So I know that there are 14 cards per color. So that means when I'm talking about green, I've got 14 cards that are green. Now, one of the things that I do have to be sure of is, just like every time I deal with fractions, what is the thing that you always have to make sure your answer of a fraction is written in?
Simplest form.
Simplest form. Okay. Sorry, you can't get away from it. You're going to be seeing simplest form with fractions all the time. So we have to go simplest form. So 14 over 56. Again, it's the kind of thing where you can always try to figure out what is the largest number that will divide evenly into both, or you can just start trying numbers and work your way down. If you wanted to look at this and say, hey, they're both even, I want to divide by 2, you can do that. Divide by 2, and 14 divided by 2 is 7. And 56 divided by 2 is going to be 56 divided by 2 is going to be 28. But now look at 7 and 28. What are they both divisible by? Are 7 and 28 divisible by anything? Not, right? So hold on a second. Think about, what are they both divisible by?
7.
They're both divisible by 7, right? And 7 divided by 7 is 1. 28 divided by 7 is 4. Now look at this. If I divided by 2 and I divided by 7, the largest number that both of them are divisible by is 14, but I probably would have never figured that out. I might have tried 7. Originally, I was wanting to try 7, but just looking at it being even. But I want you to be able to see that even if you do not know what the largest number is, I can always start with the easiest thing that I know, and I can keep working until I'm sure I am in simplest form. Okay? So we have a 1 in 4 chance of pulling a green card, or we have a probability of 1/4. Okay. Again, if I wanted to express that as a percent, that would be 25% chance. So all these different things that we can look at. All righty. Now our next one, it says, what is the probability of drawing an even yellow card? All right, so let's think. If I'm numbered from 1 to 14, how many of those cards have even numbers on them? So 2, 4, 6, 8, 10, 12, 14. So I have 7 chances of getting an even yellow. So 7 goes in my numerator. My total cards, still 56. So I've got the fraction of 7 over 56. Not in simplest form yet. So what are they both divisible by?
7.
7. 7 divided by 7 is 1. 56 divided by 7 is 8. So I could read this as I have a 1 in 8 chance of drawing an even yellow, or I have probability of 1/8. Excuse me. Sorry, from all my talking today, my voice keeps going out and my throat keeps getting dry and I keep on coughing. So, or if I wanted to express that as a percent, that would be 12.5% chance. Remember, I would divide 1 by 8 and get decimal 125, move my decimal 2 places to make a percent. So I'd have a 12.5% chance. Okay. Now let's look at the next one. What is the probability of drawing a 7? Out of the 56 cards, how many 7s do I have? How many color choices do I have? I've got 4 color choices, right? So that means I only have 4 7s. I would have a red 7 and a yellow 7 and a green 7 and a black 7, okay? So I only have 4 7s. So 4 out of 56. Again, I look at it, it is not in simplest form. So if you looked at it and didn't know immediately that 4 would go into 56, you could just start by saying, okay, they're both even, so I'm going to divide by 2. 4 divided by 2 is 2. 56 divided by 2 is 28. They're still even, so I divide by 2 again. 2 divided by 2 is 1. 28 divided by 2 is 14. So you have a 1 out of 14 chance, or 1/14. Or again, if you wanted to convert that to a percent, you would divide 1 by 14 and see that that is 0.071 with some numbers repeat or going on. So basically it would be like a 7% chance. Okay. Now, finally, the probability of drawing a card that is a multiple of 5. All right, so think about the numbers 0 through 14. What I only have, how many multiples of 5 am I going to have in 0 through 14? I mean 1 through 14. You have the number 5 and the number 10, and that's going to be it. So if I have a 5 and 10 for red, that's 2, 5 and 10 for yellow, 5 and 10 for green, 5 and 10 for black. I have 8 possibilities of drawing a multiple of 5. So I have 8 out of 56 total. So basically my numerator is just how many chances do I have of this happening? And my bottom is what are the total number of possibilities? So again, 8 out of 56, both are divisible by 8. 8 divided by 8 is 1. 56 divided by 8 is 7. So I have a 1 out of 7 chance. 1 divided by 7 is like 0.14, so it would be a 14% chance if you were looking at it as a decimal. Any questions on these? Does everybody feel okay being able to identify which number goes in the numerator, which one goes in the denominator, and how to figure out what my numbers are, numerator and denominator? Is everybody good with that? Awesome. All right. Let's look at our activities on 153. It says find probabilities. It says, what is the probability when you flip a coin? What is the probability of getting tails? Okay, so let's think about this. Remember, I have my I have in my numerator, I've got my desired results or what I want to happen. My denominator, I've got my total possibilities. So when I'm flipping a coin, how many possibilities do I have? I can either get heads or tails, right? So I only have 2 possible outcomes. So that goes in my denominator. How many chances of getting tails do I have? Just 1. So I have a 1 in 2 chance, or I could read that as a 50% probability. I have a 50% chance that I'm going to get tails. I have a 50% chance that I'm going to get heads too. Okay. So basically what I'm looking at when I think about what I'm doing, I think about, okay, if I'm flipping a coin, what's my total outcomes? 2. Getting tails is just one of those. So I write that as a fraction, 1/2. Let's look at the next one. When you roll a die, what is the probability of getting a 2? When I roll a die, how many possible numbers do I have on a die? I have 1 through 6. Good. I have 6 possibilities. So when I roll it, I could get a 1, a 2, a 3, a 4, a 5, or a 6. Okay. And remember, this is just when I roll one of them. So my probability of getting a 2 when I roll a die is going to be 1 out of 6. The next one, when you roll a die, what is the probability of rolling an even number? So again, we know my total possibilities is 6. How many even numbers do I have on a die? I've got 2, I've got 4, and I have 6. All right, so I have 3 chances of an even number. So that means I've got 3 out of 6. I've got to reduce that to the simplest form fraction. Both are divisible by 3, and I know that 3/6 is equal to 1/2. And then finally it says, what is the probability, when you roll a die, what is the probability of rolling a number less than 10? All right, so think about this. If I have 6 possible, what's my possibility of rolling a number below 10? I've got 6 chances of rolling below a 10, right? Because it doesn't matter what I roll on my die, it's going to be below 10. So I have 6 out of 6 chances. 6 divided by 6 is a whole number 1. So I am guaranteed, I have 100% chance of rolling a number below 10. So what we've been looking at here with each of these probabilities, we've been looking at numbers that go between 0 and 100%. Or 0 and 1. Okay, so think about I'm going to make up one for you. What would be the probability of rolling a 0 on a die? I would have no chances, right? So that would be a 0 out of 6, and 0 divided by 6 is 0. So there's 0% chance of rolling a 0. Okay, so that's what I mean by when you have a 0% chance. That would be like when we were looking at our cards and we've got the deck that has red, yellow, green, and black. And I say, what is your chance of drawing a blue card? There are no blue cards, so you have a 0% chance of that happening. Okay. Any questions so far? All righty. So that's just basic probability. I'm looking at what I want to happen compared to everything that can possibly happen. Okay, so that's the fraction form that I set it up in. And then I have to reduce my fraction to simplest form. So we are going to just go ahead and keep on moving. Let's see, 71 was bar graphs. So we're keeping on moving from there. And then we had line graphs. And then is that the end of my pages I've got copied? It sure is. Excuse me. All right, so now we are going to move on to lesson 73 on page 161. Lesson 73, page 161. And I'm going to take a picture of it real quick and load it on my scanner app. Okay. That wind is crazy today. It is cold outside. All right, so let me pull this in real quick. There we go. Alrighty, so starting on lesson 73. Now this is about probability and odds, okay? So when I talk about probability, like I said, I'm talking about the chance of something happening, all right? So now when we talk about odds, so let me real quick, we'll put at the top of our paper, let's go ahead and put probability is the chance of desired outcome over total, actually, let me fix that line real quick. Desired outcome over total possible outcomes. So now when we talk about odds, it says odds describes the chance or likelihood that an event will happen when compared to all the possible ways that it will not happen. So probability, we looked at all the possible ways that they could happen. With odds, we're looking at all the possible ways that it could not happen. Okay, so that's the big difference between probability and odds. So it says to compare the two formulas. This is what we looked at with probability. Probability, we looked at the number of ways that an event could occur over the total number of possible outcomes. So just like when we were talking about drawing a card out of a stack, we said, how many of those cards do I have out of the total number of cards? So now with odds, I'm looking at the total number of ways of something can occur compared to the total number of ways that it would not occur, okay? So these are the two main differences. Is here I have cannot. When probabilities are generally expressed at, while probabilities are generally expressed as percents, odds are generally expressed as ratios. So in the last ones, we also we represented those as ratios as well. We just left them as fractions. And so one of the things I also want you to get comfortable with is when you hear the word ratio, you'll hear it more in algebra than you do in pre-algebra, but as you continue through math, when you hear the word ratio, you're just thinking about a fraction. That's all a ratio is a fraction, okay? We have a numerator and a denominator. We're comparing two things. Basically, it's part to whole, just like a fraction is. That's what a ratio is. We're comparing two things. All righty. So next example says we want to find the probability and the odds. So we're going to do both things here. We're going to find the probability and the odds of rolling a 3 on a standard 6-sided die. Okay, so the event is rolling a 3. So that's what we're saying E is. E is rolling a 3. We know that there's only one chance of rolling a 3 on a die. All right, so if we're looking at probability, that means I would write it as a fraction of 1/6 because I have one chance out of 6 of rolling that 3. If I wanted to represent it as a percent, I could. So now let's think about this. For odds, okay, if there is one way that I can roll a 3, I have to subtract that from my total. So if there are 6 possible outcomes and I take rolling a 3 away, now I only have 5. Okay, so there's only one way that it can occur, but there are 5 ways that it could not occur. So I represent that as 1/5 because I have one way that it can occur, but I have 5 ways that it cannot occur. Does that make sense? Is everybody okay with that? It sounds confusing at first when you're saying, oh, this is the number of ways that it could happen compared to all the possible ways, or the number of ways that it could happen compared to the ways that it couldn't happen. All that means is I take the number of chances that it could happen away from the total of chances. So I still need to know my total, subtract my chances from that. And so now we read this as 1 to 5. Remember earlier we said we would have a 1/6 chance way of something happening. When I say out of, that's probability. Okay, when I use the word to, that's going to be with odds. So I have a 1 to 5 chance of it happening, and I have a 1/6 probability. So let's practice with this for a minute. It says a set of double 6 dominoes has 28 dominoes. Okay, so maybe you're familiar with dominoes. If you're not, you got dominoes. They're a little brick looking thing. They've got the line in the middle. You've got numbers on either side. So this is a set of double 6 dominoes, and there's 28 total. If you draw one, what is the probability that you will draw the double 6? So again, if you're not familiar with dominoes, then basically each little brick or each domino is going to have a combination of numbers, okay? So like on one side it would have a 1, on one side it would have a 1, on one side it would be a 1, then a 2, then a 1, then a 3, and a 1, then a 4, and it goes through all the combinations of being able to have, numbers together. So there is only one double 6 in the whole set of dominoes, okay? There's only one. So it has asked me the probability of a double 6. So I know that if there's only one, but there are 28 total, then I have a 1/28 chance that it will be. So my probability of a double 6 equals 1/28. Again, like I said, if you want to express it as a decimal, I would just divide 1 divided by 28. And that gives me about a 3.6% chance, okay? Now, one of the things I want to mention, as you guys are working now, since we're in the second half of our year, you are okay to use a calculator, okay? So going forward, unless there's a time where I say do not use a calculator on this, y'all are okay to use a calculator, all right? So like in this situation, if your directions told you to express your probability as a percent, go ahead and write as a fraction and then put equals, and then you could get your calculator and do 1 divided by 28 and then convert that to a percent, okay? All righty. So now we're shifting and we're talking about the odds in favor. We just looked at the probability of drawing the double six. Now it says, what are the odds in favor of you drawing the double six? So the difference here is I'm now moving to talking about odds. Okay, so I've got to think about with odds, I'm looking at my chance that it could happen. That's going to be my numerator. But now I've got to look at my denominator, and I've got to think about the chances that it could not happen. Okay, so I've got to take my number of chances that it could happen, subtract that from my denominator. So that means I have one chance of it happening. We've got a total of 28, so 28 minus 1 is 27. So my odds of a double six is 1 to 27. Now, one of the things here, notice a minute ago, I said you could write it with probability. You can go fraction or percent. Here, I can go fraction, or I can use the word 2. 1 to 27. The other way that I could write that is I could write it with a colon. Okay, so I could write it any of those ways. I could write it as a fraction. I could write it using the word 2, or I could write it using the colon, 1 to 27. Okay, that is the big difference here between probability and odds. We're using the same piece of data. We're saying that what is the chance of getting a double six? What is the probability of getting a double six? What are the odds of getting a double six? Okay, we're using the exact same thing, but we've got two different answers. Now it says, what are the odds against you drawing the double six? So if I know that I have one chance of drawing a double six, how many chances do I have of not getting a double six? I'd have 27, right? So odds of not double six. So if I have a total of 28 dominoes and there's only one double six, then I've got 27 other dominoes that I could draw. But now I've got to look at my denominator. So again, if 27 is my chance of it happening, I've got to subtract that from my total, and 28 minus 27 is 1. So I could write that as 27 over 1, or I could write that as 27 to 1, or I could write it as 27 with a colon then a 1. Okay, so I have a 27 to 1 chance of getting something that is not a double six, but I only have a 1 to 27 chance of getting the double six. So I can see how, looking at my probability, looking at my odds, I can see that it's not a huge chance of getting the double six. I have a better chance of pulling something else. All right, it is break time. So we are going to go ahead and take a break. We will come back and continue with this. So go ahead and take a 5-minute break. All righty, we'll go ahead and come on back. Okay, so we left off and we were looking at the odds against you drawing the double six. So we were looking at the comparison of the odds in favor of it happening and the odds against it. And we can see that they're flip-flopped, okay? When we flip-flop those, remember those are called reciprocals. When I flip-flop my numerator and denominator, it's called the reciprocal of the number. So I can see that the odds in favor are 1 to 27. The odds against are 27 to 1. All right, let's look at the last one here. It says if a game states that there is one winning piece and the odds of winning are 1 to 5,000, how many total game pieces are available? So let's think about this for a minute. It said my odds are 1 to 5,000. Okay, so remember that when I'm taking this number into account with odds, that means I have taken away the chance of something happening. So what is their number, the total number of game pieces if my odds are 1 to 5,000?
5,001, right?
5,001, yeah. So there are 5,001 game pieces. Okay, so I had to take whatever that number is and add back the number that are possible. Okay, any questions on that one? All righty, so let's go ahead and look on down at activities 2. And it says using a standard 6-sided game die, find the probability of rolling each of the following. Okay, so we're looking at probability here. All right, so just a second, let me go back to my page. Okay, so we're looking at this one and it says so in this section we're going to be dealing only with probability. On the next page we'll be looking at odds. Okay, so we're looking at the probability of rolling a 6. Okay, so we've got to think about how many 6s do I have on a 6-sided game die. So what is my chance of rolling a 6? How many 6s do I have? I only have 1. How many total possibilities do I have? I have 6. So 1 out of 6. And again, we could write that as a decimal if I wanted to. I could write that as a 16.6 repeating percent. Okay, so now the next one says, what is the probability of rolling an even number? So again, I know I have 6 chances or 6 total possibilities. So even numbers, I could roll a 2, a 4, or a 6. So I have 3 out of 6 chances. So 3 out of 6 reduces to 1/2, or I can also call that 50%. Now, for an odd number, again, how many odds do I have? So the probability of an odd number, I know I have a total of 6 chances. So think about my odds. I have a number 1, a 3, and a 5. So again, I only have 3 possibilities out of 6. So again, that's going to equal 1/2, which is equal to 50%. My next one, a number less than 5. Probability of a number less than 5. Again, my total possibilities is 6. So a number less than 5, I could roll a 4, a 3, a 2, or a 1. So I have 4 chances out of 6. So I would reduce that. That would reduce to 2/3. But then I can also put that 2/3 as a decimal would be 66.6 repeating percent if I wrote it as a percent. Okay, so now let's look over on the next page and we are calculating odds in favor of. So now we're looking at odds in favor. Again, standard 6-sided die. We're doing the exact same things that we just looked at, but we're looking at the odds in favor of it. And then in a minute, we're going to look at the odds against it. All right, so odds in favor. Odds in favor of 6. So how many chances did we say we had of getting a 6? There's only 1. Since we have a total possible of 6 chances, we have to subtract 1 from 6 to get 5. So we have a 1 to 5. We have 1 to 5 odds, or we can write that as 1 to 5 with a colon. Okay. Again, the next one with our even number. Remember, we said we have a chance of 3 even numbers. But now we've got to think about what our denominator is going to be. Earlier when we did probability, there were 6 possibilities. Now I have to take my 6 possibilities and subtract that. Subtract 3 from that. So 6 minus 3 is 3. Now I have 3 over 3, which is equal to 1 over 1. Now, one of the differences here is I would go ahead and write this as a 1-to-1. I don't want to go ahead and say it's a probability. It's an odd, the odds of 1. I have to say the odds are 1-to-1. Okay. So I would still leave this as 1-to-1. I would not simplify it just to a whole number 1 and go to 100%. That would be probability. And then finally, or not finally, sorry, now an odd number, I'm going to be the same thing. We looked at that earlier and we saw that the probability was the same so here with an odd number, I have 3 out of 3, or 3 to 3, which reduces to 1-to-1. So I can write that like that. Now my number less than 5. We already said that we've got 4 numbers less than 5. If we have 6 possible numbers, we have to subtract the 4 from 6. So that leaves 2. So now I have 4 to 2. I'm going to reduce that, and that would be 2 over 1. So I'm going to leave it as 2-to-1. Because I usually write these as ratios, or I write them with my colon saying 2-to-1, I have to keep 2 numbers there. Even if I know 2 divided by 1 is 2, but I cannot represent odds as a whole number. I couldn't just say the odds are 2. I have to say the odds are 2-to-1, because you have 2 times of a better chance of that happening. Okay. So odds have to be represented as 2 numbers with a colon in between them, 2-to-1, or you can leave it as a fraction, but it has to have a numerator and a denominator. So those were odds in favor. Now we're going to look at odds against. Okay, so now when we say, what are the odds against rolling a 6? Remember earlier, the odds in favor of getting a 6 was a 1, or the number of chances. So now if it's against, that means I have 5 chances of getting something other than a 6. But now I've got to subtract that from my total number. So 6 minus 5 is 1. So I have a 5-to-1 odds against getting a 6. My next one, odds against getting an even number. So think about if there were 3 even numbers, then that means I have 3 chances of not getting an even number. So again, I'm still at 3 to 3 here, which reduces as 1-to-1, which is 1-to-1. So again, that whole even and odd, if they're half and half, you still have a 1-to-1 chance. Okay. Not half and half, but if you have the same numerator, same denominator, every single time that's going to reduce to a 1-to-1 chance. So anytime you're doing odds in favor or odds against, and I have the same numerator as denominator. That reduces to 1/1, so I leave it as 1:1. And then number less than 5. Okay, so I've got to think about, sorry, I'm about to sneeze. Excuse me. So number less than 5, again, I'm thinking about what are my chances of not rolling a number less than 5. So that means my odds against it, that means I only have 2 here. I could roll a 5 or I could roll a 6. So that means I only have 2 there. I'm sorry, I wrote that wrong. Since I only have 2 chances of it happening, my odds against it would be a 4. Okay, so the odds against, I have a 4. My total number there, again, I have to, oh, I wrote that right. Sorry, I looked at the wrong place. So when I'm doing my odds against, rolling a number less than 5. So I only have 2 chances of rolling a 5 or a 6. And then so I have to take that 2 and subtract it from 6 total, and that's 4. So again, I have to reduce it to 1/2. So I'd have to write that as 1/2. Okay. The main thing to pay attention to, I think we're pretty good with knowing the difference between probability and odds. But then we have to be real careful when we think about odds in favor of and odds against. Because basically when I'm talking about odds in favor of, I'm still looking at what are the chances of this happening, and I just have to alter that total possible chances in the bottom. But when I go odds against, I'm having to flip-flop my numbers there and subtract to find my odds against. I have to consider the odds in favor, subtract that from my total, find the odds against it, okay? So let me see what we're going to do. I want to practice this some more, but there's really not more practice in the book. So what I'm going to do, let me pull up a sheet real quick. And what I'm going to do is I will email y'all this in just a bit. And what we'll do, hold on just a second. I think this one. All right, so what I'm going to do is I'm going to share this with you, and we're going to work through a couple of these columns. And then what I'm going to do is I'm going to email this to you for you to either copy onto a piece of paper and finish up for homework, or you can print the sheet and write directly, on it. It's up to you, just depending on if it's easier for you just to do a whole new sheet of notebook paper, or if you want to print it, it's totally up to you. So this kind of goes through, and we're looking at probability, odds in favor, and odds against, okay? So let's take a look at it. So it has the chart listed where we have flipping a coin, okay? So the first thing we want to look at is what are the number of possible outcomes? So what are the number of possible outcomes for flipping a coin? Earlier we talked about that. We just have heads and tails, so we only have a possibility of 2. So I put 2, whoop, I didn't, yeah, I did. I just didn't go back to it. Sorry, hang on. It wouldn't let me write on it. Come on. Here we go. All right, so the number of possible outcomes when we talk about flipping a coin, we have two possible outcomes. So now they're talking about our desired event is flipping tails, okay? So our desired event is tails. So how many chances do I get of tails out of my total possible? So remember probability. What I'm going to do is on the top of this, and when I send it, actually what I'll do is I'll send it to you like I've got it right now. We're going to fill everything out. So when I actually email this sheet to you, I'll already have what I've written on here. So remember probability, I'm going to go ahead and put our formula where P of E equals number of ways E can occur over total possible outcomes. Okay, so that's probability. When we do odds in favor, my odds in favor is the number of ways E can occur over the number of ways E cannot occur. Okay, so then when I do odds against, I have got my number of ways E cannot occur over number of ways E can occur. Okay, let me erase this line right here so it doesn't, it doesn't look like it's a fraction. All right, so let's take a look at the first one. So we said we have a total possible outcome of 2 when I flip a coin. I'm looking for tails. So the probability of tails occurring, I have a 1 out of 2 possibilities. Okay. So now we've got to look at what are the odds in favor of this happening. Okay, so again, the number of chances that it could occur is still 1, but now I have to subtract that chance of it occurring from my total amount. And 2 minus 1 is 1. So my odds in favor ends up being 1 to 1. Okay, so 1 to 1. Now when I look at my odds against it, again, I'm looking at, there's 1 chance that it cannot occur over 1 chance that it can. So it's still 1 to 1. Now what we're going to do is we're going to look at the next one, rolling a 6-sided die. I know that the number of possible outcomes when I roll a die is 6. Now I'm looking at the chance of rolling a 2. I know that I have 1 chance of rolling a 2 out of 6. So I can write that as, I can just leave it as a fraction, 1 over 6. So when I go to my odds in favor, I know I still have one chance of rolling a 2, but now what I've got to do is I take my 6 total possibilities, subtract 1, and now my odds in favor are 1/5, which I would write as 1 to 5. So now that means my odds against it are just flip-flopped my odds in favor. So if my odds, so if my odds in favor are 1 to 5, then I know my odds against are 5 to 1. Okay, so all I've done, so my odds in favor and my odds against are always just going to be flip-flopped. Now with 1 to 1, even when I flip 1 to 1, it's still 1 to 1, okay? So with that one, 1 to 1 is always going to be 1 to 1, whether it's in favor or against. But notice that when I'm looking at odds in favor and odds against, if in favor it's 1 to 5, against it's going to be 5 to 1. Okay. Let's do one more. Okay, again, rolling a 6-sided die. Actually, let's go to one of the ones at the bottom because we've done a rolling a die. I'm kind of tired of that one. Let's look at integers, okay? All right, so let's stop and think. You're probably going, integers? Oh, I remember talking about integers at the beginning of the year. Think about when we talked about our types of numbers and we talked about integers, okay? What did I tell you that I wanted you to picture in your mind when you hear the word integer? Does anybody remember?
A number scale, right?
Our number line, okay? So when we talk about integers, we're talking about positive and negative numbers, okay? So we're talking about positive and negative numbers, but positive and negative whole numbers, okay? So when we're talking about, like when this says choose an integer from 1 to 25, I'm only talking about whole numbers. I'm not talking about 25.2 and 25.252 and 25.719. I'm not talking about fractions and decimals. I'm not talking about 22 and a half. I'm not considering fractions and decimals because there's a whole bunch of those. There's an infinite number, okay? So when I say choose an integer from 1 to 25, basically I'm just saying whole numbers between 1 and 25, okay? So how many of those are there? How many numbers are between 1 and 25? 25, right? So let's look at the last one. I have 25 possible numbers. Now let's look at this one. It says now I've got to look at prime numbers. Now we've got to start remembering back to what is a prime number. Remember, we have prime numbers and we have composite numbers. Thinking about when we did prime factorization and we had to break down our numbers and we did our little number trees, or we did the number ladders and we broke them down into prime factors. Remember, prime numbers are numbers that are only divisible by the number 1 and itself. Okay, it's not divisible by any other numbers. So prime numbers between 1 and 25, think about that. My smallest prime number, remember, is 2. The number 1 is neither prime nor composite. So I'm not going to count 1 in this number. I'm going to start with 2. So I know that 2 is prime, 3 is prime, 5, 7, 11, 13, 17, 19, and 23. Did I miss any? 2, 3, 5, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Okay, so those are my prime numbers. How many prime numbers are there between 1 and 25? 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have 9 prime numbers out of a total possibility of 25. So my probability of getting a prime number would be 9 out of 25. That cannot be reduced because there's nothing that will divide evenly into 9 and 25. So there's my probability there. Now I've got to think about my odds in favor. Remember, I still have 9 as a possibility, but now I have to take that 9 away from my total number. So basically I have to subtract 25 minus 9, and that's going to give me 16. So now I have 9 to 16, or 9 over 16. So I'm going to, let me write that a little bit smaller so I can write it as a, so I've got 9 over 16. So that equals 9 to 16 odds. So if my odds in favor are 9 to 16, what do I know my odds against are going to be? I'm going to flip them. So then it's going to be 16 to 9. Is everybody good with knowing that odds in favor and odds against are opposite? So I just flip them, okay? So it's odds in favor. If it's 9 to 16, then odds against will be 16 to 9. So when I look at that, do I have a better chance of getting a prime number or not? If my odds are in favor is 9 to 16, that means I have 9 chances of getting one and 16 chances of not getting it. So I have a higher chance of not getting a prime number than I do getting a prime number. So that's how you look at those numbers. I have, this is how many chances I have of getting a prime. This is how many chances I have of getting something else, or getting a composite number. Okay, so I have a greater chance of getting a composite than I do a prime. Okay, so like I said, I don't want to push on to another section just yet. So what I'm going to do is I am going to email you guys this sheet with this information written on it. Okay, and then your homework will be to finish this sheet. I don't think I have anything else that I want you to do. Let me make sure. Let me flip back. That was lesson range. Flip through because I know since our book, since I'm doing it in different order. All right, yeah, it looks like that's all we're going to have for homework. So what I'll do is I will get ready to email this to you guys, and we are actually done for the day. So we're finishing up a good bit earlier today. So anyway, what I'm going to do is let me get this ready to go. And then that way, it's not going to take it this way. What I'm going to do is I'm going to send it to myself, and then I'll be able to send it out in a mass email altogether. Alrighty, so be on the lookout for this. This will be due on Monday. And so I'll go ahead and send it over right now. So if you want to work on it right now, you can. And then that way, actually, let's see. Oh, what did it do? Oh, get rid of that. Now let's see if it'll let me do it from here. Forward, include attachment. It may just be the iPad won't let it do. So what I'll do is I'll pull it up on my phone, and I can send it in a group message on my phone. Okay, so another thing for you to know is that on What I will do is by tomorrow, I'm going to be sending you our packet that will go along with our mean, median, mode, and range, and probability and odds and all that stuff. I'm going to go ahead and send you the packet that we're going to start working in next week. I'll go ahead and send that to you guys by tomorrow, so you have time to print it out for next Monday. Okay. So I'll send you this sheet in just a minute. That will be for homework for Monday. I'll also send you by tomorrow the packet that we will need for Monday. Okay. Any questions? Just remember that if there is anything that you are having trouble with, please be sure to let me know. Okay. Don't struggle. Don't be totally left behind. Don't be so confused and just not ask. Let me know. And like I said, we can either set up some one-on-one time or whatever to help you out. Okay. Just be sure to look at those steps for probability and odds in favor and odds against. Just follow that pattern, follow the formula that we have, and I think you'll do just fine with that. Okay. All righty. Well, if you have questions, you're welcome to stick around. If you are ready to go, you may go. And I hope y'all have a great weekend. Stay warm. I guess it's going to be pretty chilly. All right. Bye, guys.
Bye.
Bye-bye.